Welcome to fifth semester. Welcome to fifth semester MCA program, Big Data Analytics subject. I PVS one, Assistant Professor, Department of Computer Science, ADIKAVI NANNAYA University, MSN Campus, Kakinada. Last sessions discussed Big Data Analytics definition, characters of Big Data Analytics, and importance of Big Data Analytics. Today we are going to discuss about patterns of a big data. Patterns of big data. What is a big data pattern? Big data patterns are aimed to reduce complexity, boost the performance of integration, and improve the result of working with new and large forms of data. The main concept of patterns to reduce complexity, the performance of integration, and improve the result of working with the new and large forms of data. The common big data design pattern based on various data layers such as data source and ingestion layer, data storage layer, and data access layer. These three types of layers discussed in the patterns of big data development. So, why use patterns in big data analytic concept? To reducing the complexity, the performance of integration, and improve the result of working with new and large forms of data. These three layers discussed in the patterns of for big data development. First layer is data sources and irrigation layer. Second one is data storage layer and data access layer. What is a data source and irrigation layer? Enterprises big data systems face a variety of data sources with non-relevant information, for example, noisy information, alongside relevant signal data, noisy and signal data. Noisy ratio is very high compressed to signals, and so filter the noisy from the parent information, handling high volumes, and the velocity of data is significant. This is the responsibility of the irrigation layer. So, for example, an enterprise database system faces a variety of data sources with non-relevant information, signals or noisy, and relevant data alongside relevant data, noisy based relevant signals data. This is the main responsibility of the irrigation layer. The common challenges in the irrigation layer are as follows: multiple data source load and porterization, ingest data indexing and tagging, data validation and cleaning, data transformation and compression. These are the common challenges in the irrigation layer as follows. So, irrigation layer of data process, data source. Yeah, for example, enterprises big data system face a variety of data sources with non-relevant information alongside relevant data. Noisy ratio is very high, compressed to signal, and so filter the noisy from the patent information, handling high volumes, and the velocity of data is significant. This is the responsibility of the irrigation layer. So, high compressed signals and filtering the noisy for parent information. This is the main function of the initiation layer. So following four challenges are initiation layer. Some common work patterns as well, including multi-source extractor, multi-destination, protocol converter. This is the common work patterns in initiation layer or data source. And just in time JST transformation, real time stream patterns. These five concepts are patterns in the initiation layer or data source and initiation layer. First one is a multi-source extractor. This pattern approach to initiation multiple data types for multiple data source efficiently is termed as a multi-source extractor. In multi-source extractor patterns, multiple data types from multiple data sources efficiently is termed as a multi-source extractor. Is extracted from the multiple data types from the multiple data access or data sources. By using a multiple data types from the multiple data sources. This is termed as a multi-source extractor. So, for example, this diagram HDFS, Spark, Scope, BigQuery, S3, MongoDB is multiple data types, is a collection of multiple data source, and data source. So data enricher, collection agent node, data enricher, collection agent node. So pictorial representation how to work a multi-extractor patterns. So multiple types of initiation layer, multiple types of data will be collected multiple source. Next, second one is multi-destination patterns. Multi-destination patterns. The multi-destination patterns is considered as a better approach to overcome all the challenges mentioned previously. Already some challenges mentioned in the initiation layer. The common challenges are four types. Already we will discuss. These challenges overcome in this pattern, multi-destination pattern. This pattern is very similar to multi-source unit. It is ready to integrate with multiple destinations. The router publisher the improved data and they broadcast it to the subscriber destination already registered owners. Publishing agent on the router. Enrich can act as a publisher as well as subscribers. These patterns act as a subscribers or publishers. These patterns to overcome all the challenges of initiation layer. This is very similar to the multi-source unit. It is ready to integrate with the multiple destinations. So combined a multiple destination to improve data and they broadcast to the subscriber destination. So publish the data. How data will publish? So the data will be integrated and published. So these diagrams in the pattern, router is there and already HDFS NoSQL storage and such 8 analytic engine, data warehouse and data mart. This is the multiple source data enrich. Already we will discuss multi-extractor data concepts. These data will collect router and after the subscriber data. So multi-destination pattern is act as a publisher and or a subscriber. We have subscriber. So all types of challenges were overcome in this pattern in initiation layer. Next, The following are the impact of the multi-destination patterns. Needs complex or additional infrastructure to manage distributed node. Needs to manage distributed data in the secured networks to ensure data security. Needs enforcement, governance, and strength practice to manage the integrity and the consistency of data. So these are the impact of the multi-destination patterns. Next, protocol converter. This is a mediator approach to provide an abstraction for the incoming data of various systems. So to provide an abstraction of for the incoming data of various systems. These protocol converter patterns provide an efficient way to ingest a variety of unstructured data from multiple data sources and different data sources. So, it is an efficient way to integrate a variety of unstructured data from multiple data sources. To collect a unstructured data from multiple data sources. In the protocol converter pattern, the indication layer holds responses such as identify the various channels of incoming events, determination incoming data structures, providing mediated service for multiple protocols into suitable links. Provide one standard way of representing incoming messages, providing handle to manage various request types, and providing abstraction from the incoming protocol layers. So all incoming data will collect and to convert the accessible information for the users. So in protocol converter, the data will be converted unstructured data from multiple sources to send the data protocol layers. So already first multi-converter, multiple extractor already discussed data source, different data tools from the different types of data. So already second concept is multi-destination. Router is there in the multi-destination, and the data will subscribe different types of users. So, but handlers is the middle version. Handler is the protocol converter. Protocol converter work is incoming data will be converted to protocol generated data. This is the main responsibility of the protocol converter. Next, just-in-a-time transfer patterns. The JIT transformation pattern is the best fit in the situation where raw data needs to be preloaded in the data source before the transformation and processing can happen. The JST transformation pattern is main responsible. Raw data needs to be preload data. Raw data needs to be preloaded in the data sources before the transformation and processing can happen. Which data will upload to the data stores before will transformation and processing that applies the data. So in this kind of business case, this pattern runs independent pre-processing batch jobs that clean, validity, collate, and transformate, and then store the transformation information into the same data store, HDFS SQL. That is, it can coexist within the data. So, which data will preload before performing a transformation and the processing process. That is the batch operation process. So already we discussed operating system, multiple processing, batch operation processing. So batch operation process applied before preloading the data. The process is cleaning, validate, and correlate and transfer. So these types of operations performed in batch processing before the raw data pre-upload to the data store. So already data source, multiple data sources are collects agent nodes, and these data raw node will be sent. So after the performance three operation, transform data 1, transform data 2, transform data 3, these three operations performed after these data will preload to the load to the data stores. Next, real-time streaming patterns. Most modern business needs continuous and real-time processing of unstructured data for their enterprise big data application. This is a very important nowadays for using a business processing, real-time processing of unstructured data for their enterprise big data application. So real-time processing is available nowadays, processing the unstructured data to convert the structured data. Real-time streaming implements needs to have the following characteristics: minimize latency by using large in-memory. Event processors are atomic and independent of each other and so are easily scalable. Provided API application program interface for parsing the real-time information. Independent development script for any node and no centralized master node implementation. These are the implementation of real-time pattern streams. The real-time pattern streams suggest introducing a optimum number of event processing nodes to consume different input data from the various data sources and introducing listeners to process the generated events from event processing nodes into the event processing engine. So in real-time processing streaming patterns, an event processing engine is there. So that engine will generate the data source in the data, a data source in the data processing. Each and every node data will processed at the event processing engine. Your processing engine have a sizable in-memory capacity, and the event processors get triggered by a specific event. The triggered or alert is responsible for publishing the result of the in-memory big data analytics to the enterprise business processing engine, and in run to get redacted to various publishing channels, mobile, COS, dashboards, and so on. So data sources and event processors and listeners and triggers alerts. So business processing engine. So in this real-time streaming patterns, the main work business processing engine. This business processing engine will collect data from triggers or alert. These triggers is different types of listeners, and listeners will collect event processor. Event processor will collect data sources, different types of data sources. So this is the nowadays we using a real-time streaming pattern for business purpose. Next layer, data storage layer. Already we'll discuss data source and integration layer. And next concept is second layer. Next concept means second layer, data storage layer. Data storage layer is responsible for acquiring all the data that are gathering from various data sources, and it is also liable for converting the collected data to a format that can be analyzed. The following section discusses more on data source layer patterns. So data storage layer will collect data from different types of data sources. So these data will be generated format that can be analyzed. A specific format will generate in the data storage layer. ACID versus base versus cap. Traditionally, RDBMS follows atomicity, consistency, isolation, and durability. This is the ACID to provide reliability for any user of the database. However, searching high volumes of big data and retrieving data from those volumes consumes any enormous amount of time. If the storage enforces ACD rule, so big data follows basically available, soft state, eventually consistent base, soft state, eventually consistent base, as a phenomenon for understanding any search in big data space. So these operations, atomicity, consistency, isolation, and durability, these ACD properties by using in data storage layer to generate a format of data. Database theory suggests that the NoSQL big databases may fundamentally satisfy two properties and relax standards on the third. And those properties are consistency, availability, and partition tolerance cap. Consistency, availability, and partition tolerance cap. With the ACD base and cap paradigm, the big data storage design patterns have gained moment and purpose. We will look at these patterns, those patterns in some details in this section. The patterns are spaced patterns, NoSQL patterns, and phyloglot patterns. Phyloglot patterns. So the three operations for ACD operations: atomicity, consistency, isolation, and durability properties, and basically available soft state, eventually consistent, and consistent availability and partition tolerance cap. These are the three operations performed in the data storage layer. So in the data storage layer, three patterns are performed: spaced patterns, NoSQL patterns, and phyloglot patterns. These spaced patterns provides a way to use traditional existing data warehouses along with big data storage such as Hadoop. It can act as a phased for the enterprise data warehouse and business intelligence too. In the phased patterns, record patterns, the data for the different data source gets aggregated into HDFS before any transformation or even before loading to the traditional existing data warehouse. The record patterns allows structured data storage even after being ingested to HDFS in the form of structured storage in an RDBMS or in NoSQL databases or in a memory case. The phased patterns ensure reduced data size as only the necessary data reside in the structured storage as well as the phased faster access from the storage. So different types of data sources. Ingestion layers is already over. Next, data storage layer. HDFS, HBase, and Clouder. Heavy RDBMS, packed implementation in memory caches. So traditional existing data warehouse, Teradata warehouse. This is the record patterns. Next, NoSQL patterns. These patterns entitled getting NoSQL alternative in place of traditional RDBMS to facilitate the rapid access and querying of big data. The NoSQL database stores data in a columnar non-relational style. It can store data in relational databases and HDFS, and HDFS Hadoop database system. This data can be distributed across data nodes and fetching very query types of NoSQL database in brief. So, columnar databases scenarios: application that needs to fetch continuous related column family based on a given string, for example, search engine, vendor application tools, SAP HNA, IBDB to VLU, XMDB, EXA SOL, IBM Infromex, MySQL Server, MongoDB. Key value pair databases needs to hashtag application refer to the big data workload patterns given in the section. Rates the Oracle NoSQL DB, Linux DBM, Dynamo, and Cassandra. So the graph databases, a recommendation engine application that provides evaluation of similar or to like, for example, user that brought this item also brought orange DB, taxotype, data tax, Neo 4G, Oracle Sparkle and Graph, Apache Orient DB, Teradata, Astar. Document databases, applications that evaluate full management of social media data and are no enterprise data. RocDB, Apache Allied Section, Informatics, Jacobet, MongoDB, and Apache SYLLABUS. So this is the new SQL, no SQL patterns. Next, pylogap patterns. Traditional RDBMS and multiple data stores, files, CMS, and so on coexist with the big data types, NoSQL HDFS to solve business problems. Most modern business cases needs to coexisting of legacy databases. At this same time, they would need to adopt the latest big data techniques as well. Replacing the entire system is not visible and also impracticable. The pylogap patterns provide an efficiency way to combine and use multiple types of storage methods such as Hadoop and RDBMS. Big data application coexist in the storage solution. So this is the pylogap patterns to introduce different types of storage mechanisms such as an Hadoop and RDBMS. So HDF's data downstream system, HDFS, digital images, transformation data, application, content management system, CMS, RDBMS in memory cache. So, pylogap patterns using a different types of storage mechanism techniques such as Hadoop and RDBMS. Next, last layer, data access layer. So data storage layer, data source layer, data storage layer, and data access layer. Data access in the traditional database involves JDBS, Java development, Java distributed base system, JDBS, connections and HTTP access for document. However, in the big data, the data access with the conventional method does take too much time to fetch event with the cache memory implementation as the volume of the data is so high. So we need a mechanism to fetch the data efficiently and quickly with a reduced development life cycle, power maintenance cost and so on. Data access patterns mainly focus on accessing big data resources of two primary concepts: end-to-end user-driven API access through simple inquiries, developer API access browser through API methods. In this connection, we will discuss the following data access patterns that hold efficient data access, improved performance, reduced development lifecycle, and low maintenance cost for broadcast the data access. Connection patterns: lightweight stateless pattern, service locator pattern, near real-time pattern, and tag transfer pattern. So data access layer by using JDBC connection and HTTP accessor. So data access patterns focus on mainly end-to-end user-driven API access, developer API access. Now, this is the patterns for big data development. One is the data source and integration layer, and second one is the data storage layer, and third one is the data. Fourth concept, data in the warehouse. Already data warehouse. Data warehouse means data warehouse is a collection of multiple sources data stored in a single station in a repository storages. Data warehouse is a collection from different sources of information in a specific manner, in a specific way, in a specific patterns. Data warehouse is basically the collection of data from various heterogeneous sources. It is the main component of the business intelligence system where analysis and management of data are done, which is further used to improve decision making. It involves the process of extraction, loading, and transformation for providing the data for analysis. Data warehouses are also used to perform queries on a large amount of data. It uses data from various relational databases and application log files. So what is the difference between big data and data warehouse? Big data is the data which is enormous from on which technology can be applied. Data warehouse is the collection of historical data from different operations in enterprises. Big data is a technology to store and manage a large amount of data. Data warehouse is an architecture used to organize the data. In big data, it takes structured, non-structured, and semi-structured data as an input. It is only takes structured data as an input. In big data, does processing by using distributed file systems, but data warehouse does not use distributed file system for processing. In big data, does not follow any SQL queries to fetch data from databases. In data warehousing, we use SQL queries to fetch data from relational databases. Apache Adobe can be used to handle enormous amount of data. Data warehouse cannot be used to handle enormous amount of data. When new data is added, the change is data in data are stored in the form of a file which is represented by a table. When new data is added, the change in data are stored in the form of a file which is represented by a table. But in data warehouse, when new data is added, the changes in data do not directly impact to the data warehouse. In big data does not require efficient management techniques as compared to data warehouse. But in data warehouse requires more efficient management techniques as the data is collected from different departments of the enterprises. So the main differences of big data and data warehouse. Next, data in Hadoop. In big data, analytic concept using and running by the Hadoop operations. This is a very important concept. Hadoop means a open source file. Later unit I will discuss Hadoop briefly, but that but data in Hadoop in the concept. Big data is an involved term that describes any volume amount of structured, semi-structured, unstructured data that handles the potential to be mined for information. Such techniques need to be highly robust, accessible, scalable, and simple on such framework named as a Hadoop. This framework is based on a file system named HDFS, Hadoop Distributed File System, which uses the essence of distributed file system architecture and a parallel program to handle enormous amount of data stored on a commodity server. These techniques help in mining critical information. HDFS stores files in pieces and blocks. So, big data will run by using an important open source application, Hadoop. So, Hadoop stores files in pieces and names blocks. These blocks are located in random locations on the server in order to minimize the seek time for these files. Secondly, duplicate copies of these blocks are also stored the server as a backup so as to prevent loss of information. This making is robust. This is the robust technique. In order to locate these blocks, the metadata of these blocks are stored in the primary name node, while the actual data in the form of blocks are stored in the various data nodes spread across the server. This is the primary name node. These primary name node serves as a master to the data node, and hence it is also called a master slave architecture. In Hadoop mechanism system, to generate a master slave architectures, one of the master and different types of slaves. These primary name node serves as a master to the data nodes, and hence it is also called a master slave architectures. These techniques involved in the Hadoop file system. So IT professional will run the same in the Hadoop techniques by using the and big data analytics. So in big data analytics, Hadoop open source files are used in master slave architecture manner. What to do with the big data? So big data application, big data storage, big data analytics. Big data application, different types of big data applications. First one is the open source framework Hadoop and open source R programming and NoSQL databases and Linux. These are the applications of big data applications. The data connectors and data integrators. Big data storages, advanced analytics, data warehouse, relational databases. In database analytics. Next, big data analytics, analytic applications, alerts and dashboards, MD analytics, reports, queries, web services, BI abstraction. These are the works in big data applications and storages and analytics. So in this unit, the following concepts are already discussed. Data structures in Java concepts and introduction to the big data concepts. Next, we will discuss it. Next session, second unit, Hadoop.